The answer is D.
The answer is D.
Yeah.
Okay, so here we should consider this part. It is D. So we can say what? And this is BRGW, right? Without loss of generality, and we multiply it by what?
We multiply by 4 factorial.
Exact, 4 factorial. Then this one can be what or what?
There's 2 options.
Yes, what are the options?
BG or GB.
Yes, PG or GB. So in this case, how many cases are there for the rest? In the first case.
We have 2 cases.
Yes, because BRB, RBR, right?
Yeah.
2 cases. We can say BRB or RBR.
RBR.
What about this one?
That one we can have BRG again.
Yes, why it has to be only BRG?
Because we can't have RB because then the bottom right square has 2 B's.
Yeah, because here if you consider this one BW, this one WG, so the only choice for this one is what?
Only choice for that is R.
Exactly, because it is R if you consider this one is B. If you consider this one BW, RG, right?
Yeah.
So 4 factorial times 2 plus 1, which is 3, which is 24 times 3, 72. Good job. Your answer is completely correct. Now let's try Singapore problem. It is SMO. Open. I think it was for 2019. Okay, so try this problem first on your own, okay?
Okay.
It is exactly, I agree, it is exactly like previous problem. It's
yeah, but it's
7.
way bigger table.
Yes, the size is large, right?
Yeah.
The previous one was for 3 by 3. Here it says for 7 by 14. So try a bit this one first on your own. Let me know if you want a hint.
Could I have a hint?
Okay, sure. So here one useful idea, I can say the most useful idea in BMO is what?
Simple K.
Small examples, right?
Yeah.
Okay, now let's try to solve it. For 3 by 3, we said the answer is what for 3 by 3?
72.
72. Now let's, the next one after 3 by 3, we can say is what? After 3 by 3, we can check what?
3 by 4.
Exactly. So calculate 3 by 4 first on your own. This problem, the approach that we want to use for this problem, because it is similar to a small example, and generalize the idea and then prove it. Do you agree it is so much similar to BMO1?
Yeah.
Because in BMO1, in most of the problems, you should use a small example and find the idea and then prove it. We want to do exactly the same thing here. So calculate 3 by 4 is what?
I got 4 factorial times 5.
You've got what?
4 factorial times 5.
4 factorial times 5. Okay, let's check. Here, let me copy. Again, let's try it from here. we say SIMO here. Then for this one, we have two cases, right? And for this one also two cases, right?
Mm-hmm.
So the first one can be SM or it can be IOMS, right? Agreed?
Yeah.
Okay,
Yeah.
now we can say something about this table. What can we say?
It has to be SI starting at the bottom.
Yes. Because of this part.
Yeah.
Because we can say it is not OM because of this part, not this one. So it has to be I. And as you can see, look, when it is not similar to this one, for example, look, it is SM. When you write MS in reverse order, then it will be better because we can determine some other cells, right?
Yeah.
So for example, it is if for this column we have in the reverse order, so then it is I, then MOIS, OISM, and then how many cases do we have for this column?
We have either 2
Two. What are the cases? What are the two cases?
OIO or IOI.
Yes. So two cases. Here we
Yeah.
cannot say anything, so we should consider next column. Next column is what or what?
Next column.
These two cells.
Those two. But they can either be OI or IO.
Yes. Let's write with green. If it is IO, if it is OI. Again, if we have reverse order like this for this column, then you can determine, for example, this is OMI, so this cell should be what?
S.
Exactly, this cell has to be S. Then the rest will be unique because it will be like exactly first column, right? You can check it like this one, like this one, like this one. Oh, but maybe like these, all columns, all pairs are same. So how many cases do we have for last row?
2.
2. 2 plus 1 plus 2. So as you can see, the column that for the first time has is not equal to the corresponding column is good. For example, look here, if the first column is this instead of SMMS, if first column is this one, or if all of them are similar. So we can use this approach, right? Now by the same approach, try to calculate 3 by 5. Then we try to generalize it for 3 by n, okay?
What is the same approach? What is the approach?
Look, do you agree order of this one is SMIO, right?
Yeah.
So one case is that all of them have same order, means SMIO, right? Or
Yeah.
maybe one of them, at least one of them has not the same order, okay? Like what? Here the first one is this column. Look, SM
Yeah.
is similar to this, but here it is not equal to IOOI. So it is the
Yeah.
first column that doesn't have the order. In this case, the first column is this column that doesn't have the same order. Means MSSM, right?
Right.
Okay, now this column is important because when you have one column like this, then you can determine this row, right?
Yeah.
Okay, now we want to generalize for 3 by n. If you think it's easy, but I think it's better to solve 3 by 5, then generalize it for 3 by n, okay? Try to calculate 3 by 5, then we generalize it for 3 by n, then we work on this one. Try to find this one, 3 by 5.
I'm not sure whether I got this right because I got it has to be false factorial times 9.
You found 4 factorial times 9?
Yeah, but I feel like it doesn't really fit.
Okay, let's check. And we want to find an ideal like this to, for example, be able to generalize it. So let's check 3 by 9 first. 3 by 5. I think this size is enough. Okay. So 3, 1, 2, 3, 4. Okay, again we can say SIMO, right? So here maybe all of them are same. Let me make it a smaller and also see. Maybe all of them are same, means SMIO SM, right? Maybe the first one is different. The first one that is different is this column, maybe this column, maybe this column. Do you agree we have these 4 cases?
Right, yeah.
So if this column is different, then this column should be what?
MS. MS.
Exactly. If the first column that is different is this one, then here it's what? Here it's what?
SMOI.
SMOI. What about this one?
SMIOMS.
SMIOMS. Okay. Now let's fill. This one has how many cases?
That one has 2 cases.
2 cases. Here we can determine this row. This row is what?
This row has to be SIM.
Yes, because this cell is not equal to MOS, so it should be I. Then this one is S, this one is M. Then can you tell me for the rest of the table how many cases are there?
There's 4.
Is 4 exactly, because for this column, these 2 columns are not related to each other. Here, IOI or OIO. This one, MSM or SMS. So
Yeah.
2 squared, right? Now
Yeah.
here, this column would be what? This row.
That has to be SISO.
SISO, because of this one. When you have one thing that is not equal, it has different order like this, then this row will be unique and will be exactly this row. Because OMI here has to be S, then OIS, so this one has how many cases?
Yeah. That one has 2.
Yes. And what about the last row?
That last row only has 1 case.
1 case.
Yeah.
Yes, because SOM here, IMSIS. So now you can say 3 by 5 would be 4, 2, 6, 2, 8. Good job. Your answer is completely correct. Okay. Now, by exactly this approach, we want to find 3 by n. If you think 3 by n is hard, you can calculate 3 by 6 and 3 by n. But I think from here, because we can use exactly same approach to find 3 by n. Okay, try 3 by n first on your own. Okay.
Okay, I got it, I think.
Okay, can you say it is what?
Okay, so it would be fourth factorial times 2 to the power of n minus 2 plus 1.
4 factorial times what?
Bracket 2 to the power of n minus 2 plus 1.
This plus 1, so it doesn't satisfy this one. You said 8 plus 1. But look at me. Let me check. For this one. But for 3 by 3, for 3 by 3 also it's correct, right?
Yeah.
Okay, that's good. Because if we check, for example, suppose we have a 3 by n. Okay. So if you have a 3 by n, we can say, okay, first cells, if we consider 1, 2, 3, 4, n. If it is SIMO, if all of them are same, then we have 2, right? If the first one is the first one like this, then this one unique, then it would be 2 to the power of n minus 3, right? The next one 2 to the power of n minus 4 to 1, right? 2 to 1. So it would be 4 factorial 2 plus 2 to the n minus 2 minus 1. So it would be 4 factorial 2 to the n minus 2 plus 1, right? Your approach was this or different?
It was that.
Okay, good job. So we could generalize one size, right? For any
Yeah.
number n. Now then we want to find 4 by n and generalize it. Okay, so and then if we try to find 4 by something, then we can after that generalize it for 4 for n by n. So let's consider first. Let's try 4 by 4. Okay, so we have a 4 by 4 table, and we want to see the answer would be what? Try 4 by 4 first on your own. Okay.
4 factorial times 7.
4 factorial times 7.
Yeah.
Okay, let's check. Here again, we can start with SIMO, right?
Yeah.
And we can say, okay, 4 factorial. Then again, I want to use same approach. The first one is this column or none of them. Okay. Then let me move it here. So if, for example, we don't change any of them, it is this one. If we change only first one, this one, SMOI, right?
Yeah.
So how many cases do we have for the first one?
The first one we have 4, 2 squared.
2 squared.
Yeah.
Well, this one we can determine this column, right? Because it is OMS, you can say, okay, it has to be I and S and M, right? And then again, because it is ISM, this one has to be O, so this one M, this one S. So it has how many cases?
That one has 2 cases.
Exactly. What about this one?
Has just 1 case, I think.
Yes. So finished, right?
Yeah.
So 4 plus 2 is 6, 7. Now, 4 factorial times 7 was completely correct. Now you can generalize it. Let's first generalize it for 4 by 5. 4 by 5, and then after that 4 by n, and then min. Okay, so calculate 4 by 5 first, then 4 by n, then m by n. Okay, so try 4 by 5 first.
Okay. In this case, is it just 4 factorial times 2 to the power of 3 plus 2 to the power of 2 plus 2 plus 1?
It's what?
It's just 4 factorial times 1 plus 2 squared plus 2 cubed.
1 plus 2 plus 2 squared plus 2 cubed. Okay, so let's check. Here, for 4 by 5, right? For 4 by 5, we can say what? We can say, okay, 1, 2, 3, 4. We can say when we have SIMO, if all of them have same order, it will be 2 squared, right? Like this. If you fill the first one, if the first one is different, then you can fill this part and this one, then it would be 2 squared again, right? So do you agree your answer has mistake? Understood the problem is what?
Well,
Look, if we want to consider first 1 that is different, okay?
Yeah.
So let's label this one 1, 2, 3. If the first one is 1, if the first one is 2, if the first one is 3, if none of them, okay? For none, like this one, none of them are different, right?
Yeah.
So for none, it would be what?
1.
No. Pay attention here. For previous one, it was not 1, it was 2 squared.
No, it was 2. It was 2.
So 2 squared, right? Because
2.
then you can fill this, then here 2 squared, right?
Wait. If they're all the same, then oh wait, I accidentally drew a 5 times 5 table.
Yes, do you agree it's 2 squared?
Yeah.
And then if the first one is different, then it would be what?
If the first one was different, oh god. 2 squared as well.
2 squared as well. So SM, you fill all these things. So for these two columns, 2 squared, right?
Yeah.
Then what about this one?
Just 2.
2. What about
Yeah.
next one?
There's 1, then has to be.
Yes, so it is this, right?
Yeah.
So we have 2 squared plus 2 squared plus 2 plus 1, right? So
Yeah.
can you guess for 4y(n) it would be what?
4/n is probably fourth factorial times and to the n minus 3 plus 2 to the power of n minus 2.
4 factorial times what? Can you say it again? 4 factorial times what?
2 2's n minus 3.
So let me tell you something. Calculate 4/6, 4/6, exactly like this. You can consider cases. Calculate 4/6 first on your own, okay?
I can probably predict what it's going to be. 4/6. It's probably going to be 2 to the power of 3 plus 2 to the power of 2. It will be 2 times 2 to the power of 3 plus 2 to the power of 2 plus 2 plus 1.
So let me write 4 factorial times 2 to the power of what?
2 to the power of 3 times 2 plus 2 squared plus 2 plus 1.
No, it's not correct. So draw the table and try to calculate this, okay? Okay, one hint or want to keep trying?
I think I got it. Is it like the same, but instead of 2 times 2 cubed, it's 2 times 2 squared?
Mm-hmm. Yes, and then 2 times 2 squared, then what? Plus what?
It's 2 cubed plus 2 times 2 squared plus 2 plus 1.
Exactly. We have 1, 2 squared. Because of when all of them are same, we have 2 squared, right?
Yeah.
For this none, it is always. Then 2 cubed plus 2 squared plus 2 plus 1, right?
Yeah.
So for 4/n, it would be what?
4/n, it should be 2 squared plus 2 to the power of n minus 3 plus 2 to the power of n minus 2 plus all the way up to 1.
N minus 3, n minus 4 to 1, right?
Yeah.
So it would be what then? 4 factorial times what?
4 factorial 2 to the power of n minus 2 plus 3.
2 to the power of 2, 2 to the power of n minus 2 minus 1, right? So
Yeah.
it would be 4 factorial 2 to the n minus 2 plus 3, right?
Yeah.
And if we check, it would be correct because for 4/4, it's at 7. So 4 minus 2, 4 plus 3, 7. So let's consider the things here we have. For this one, we had this part. And let me tell you, only last answer. Or let's consider, okay, no problem. So for 4 by n, it is 4 factorial times 2 to the n minus 2 plus 3, right? We want to use same approach, but for m by n, okay? Before solving m by n, let's try the main problem of SMO, okay? So for this problem, for 7 by 14, try to use same approach and try to solve 7 by 14 is what, okay?
Okay, is it for factorial? Actually, I really don't think this is right. But is it 4 factorial times 2 to the power of 13 minus 1?
To the power of 13. Okay, let's check. We know 3 by n, 4 by n. 7 by 3 is what? So you said 4 factorial times what? Can you say something? So let's calculate 7 by 3 first, okay?
Okay.
So 7 by 3, if we check 7 by 3, it's not hard. And use exactly the approach I told you here, okay? So 7 by 3 is so much easier to calculate. 1, 2, 3, 4, 5, 6. So calculate this is 4 factorial times what, okay?
Is it 4 factorial times 2?
It's
Wait,
what?
actually, wait, actually, wait.
Yeah.
Yeah, actually, wait. I got 1 plus 2 to the power of 5.
Mm,
Oh, no, is it 3? No, is it just 4 factorial times 3?
it is what?
4
Can I say it
factorial.
again? So look here, if this column is different, if not, okay? So let's check both cases. If this column is, if it's the same,
then that's with 1.
it would be what?
Oh, wait, no. If it's the same, then is this 2 to the power of 5?
2 to the power of 5. If here we have ms, then it would be what?
1.
1. Finished as easy as this. We should only focus on the first column that is different. Now what about 7 by 4? It's 4 factorial times what? Okay.
Is it 2 to the power of 5 plus 1 plus 2 squared?
2 to the power of 5 plus
1 plus 2 squared. No, 2, just 2. Is it just 2?
Yes, because if all of them are same, then 2 to the power of 5. None of them, then this one. Then one column is left 2 squared, then 1. Exactly. What about 7 by 5? Try to calculate this.
Is it just 2 to the power of 5 plus 1 plus 2
yes.
squared?
So now do you agree we can calculate 7 by 14?
Yeah.
So calculate 7 by 14.
Okay. I got 4 factorial times 2 to the power of 5 plus 2 to the power of 12 minus 1.
Let me write. 7 times 14 is what?
4 factorial times 2 to the power of 5 plus 2 to the power of 12 minus 1.
Yes, plus 1 plus 2 squared. 2 to the 11. 4 factorial. You said 2 to the 5 plus 2 to the 12 minus 1. You said?
Yeah.
Okay, good job. So, if we calculate this, because we should find last answer in this problem, calculate this one and see this what, okay? It's not hard to calculate.
As in a number?
Yes, a number. And it's not so much hard to calculate In 1 minute, at most 2 minutes, you can calculate last answer. Try.
99048.
9 what?
048.
Yes, exactly. 99048. Because 2 to the 5 we know is 32, 2 to the 12 is 4096. Then you can calculate and multiply by 24. And now we want to, so we solved AMC problem for 3 by 3. This one for 7 by 14. Now I want to find for m by n. Okay, calculate the answer for m by n.
Can we scroll up to see what we had before?
Okay, sure. Here, let me, also I can do this. Is it okay now? Here it is, this part. So let me do something. Pin from the page, okay. No, let me do something. Insert the page. Okay, so it is the thing that we did for this one. Okay, now try to use these things and find m by n, okay?
Okay. Is it 4 factorial times 2 to the power of n minus 2 plus 2 to the power of n minus 2 minus 1?
Exactly. Because let me make this one, okay? You said 4 factorial times 2 to the power of n minus 2 plus 2 to the power of n minus 2 plus minus 1, right?
Yeah.
Okay, so here it is m by n. And we say, okay, let's consider first these two columns. And we can say this is SIMO. First column that is different. So I consider this one as first column, second to n minus 2. So it's 1, 2 to n minus 2, and none. For none, it would be what?
For none, it will be 2 to the power of n minus 2.
Good job. And this one is what? If this column is different, it's ms. Then we can say what?
Then we can say that's 2 to the power of n minus 3.
Yes, good job. What about second one?
Well, isn't it n minus
3? Yes, sorry. N minus 3. What about second one?
And it has to be 2 to the power of n minus 4.
N minus 4.
Yeah.
And what about this one?
2 to the power of n minus 5. Oh, wait, no, that one's 2 to just 1.
Yes. So it would be 2 to the n minus 2, and some of these elements here is 2 to the n minus 2 plus minus 1. And you should also multiply it by 4 factorial, but here, let me tell you something, and it is correct. For example, if we reach something like this, 2 to the n minus 5 plus 2 to the n minus 2 minus 1 times this, why it is wrong? I want to tell you something to decrease number of careless mistake, for example, in the exam. If you reach some answer like this, it is wrong, because we agree when for m by n we have one answer, for n by m also we have the same answer, because it is not important. So do you agree our answer? Exactly, our answer should be symmetric with respect to m and n, right?
Yeah. Yeah.
With respect to m and n. So this helps you. For example, in BMO1, maybe for example it says, okay, calculate your answer in terms of m and n, and then you reach some answer, your solution is correct, but your last answer is not symmetric with respect to m. But let me tell you, you should simplify. For example, maybe you reach this answer and you say, okay, n minus 3, n minus 4, it is not symmetric to this. But when we simplify, we reach this. It means that when you switch m and n, your last answer shouldn't change. Okay? If we write also like this, if you switch m and n, last answer would be same. So, but for example, this one, if you switch m and n, it won't be same. Okay? Understood? Okay.